While NASA's website stays frozen due to the government shutdown, while American telescopes sit idle waiting for bureaucrats to return to work, astronomers on the other side of the world kept watching. Japan. November 4th. A network of amateur and professional observers captured new images of 3I Atlas that are now spreading across social media faster than any official press release ever could. 828,000 views in 48 hours. Not from a space agency, from independent observers who didn't need permission to point their telescopes at the sky. And what these images show has created a problem for the official narrative, because the object in these photographs doesn't look like what we've been told it should look like. NASA calls it a comet, a natural ball of ice and rock from another star system, but the Japanese images reveal something NASA's carefully processed, heavily filtered images somehow failed to show: structure, geometry, patterns that ice doesn't make. Let me show you what they're seeing. The timing matters here. NASA's Mars Reconnaissance Orbiter captured high-resolution images of 3I Atlas on October 2nd. The HiRISE camera, capable of resolving details down to 30 kilometers, had a perfect side view as the object passed Mars at just 29 million kilometers distance. That was 35 days ago. Those images have not been released. NASA cites the government shutdown. Fair enough, except the shutdown started October 1st, and the images were taken October 2nd. 24 hours into the shutdown, the Mars Reconnaissance Orbiter was still operating, still collecting data, still transmitting back to Earth. Because spacecraft operations are deemed mission critical and continue during shutdowns. What stops is data processing, public release, scientific analysis. The data exists. It's sitting on servers at the Jet Propulsion Laboratory in Pasadena. And it's been sitting there for 5 weeks, while the public gets carefully curated images from less capable instruments. Enter the Japanese observers. On November 4th, multiple observation teams across Japan captured long-exposure images of 3I Atlas as it emerged from behind the sun. These weren't billion-dollar space telescopes. These were amateur setups, 20 to 40 centimeter apertures, standard CCD cameras, equipment you could buy commercially. And yet they revealed details that Hubble's July images somehow didn't show. The official Hubble image from July 21st shows a teardrop-shaped cocoon of dust around the nucleus. Fuzzy, diffuse, exactly what you'd expect from a comet's coma. The Japanese images from November 4th show something different. The central brightness isn't diffuse, it's concentrated, almost point source like a star rather than a cloud of gas and dust. And around that central point, the brightness distribution isn't symmetrical. One observer in Osaka noted that the brightness profile showed angular variations inconsistent with isotropic outgassing. That's technical language for the light isn't coming from all directions equally, like it should if this were a cloud vaporizing ice. It's coming from specific points. Here's where the data gets uncomfortable for the official story. Between October 5th and November 4th, 3I Atlas brightened by a factor of 5 in the green wavelength band. That's according to NASA's own Minor Planet Center data released November 5th, 5 times brighter in 1 month. For context, when Comet Lemon, a normal solar system comet, approached the sun during the same period, it brightened by a factor of 1.8, predictable, steady, following the inverse square law of solar radiation. 3I Atlas brightened 2.8 times faster than a normal comet at the same distance from the sun. Loeb calculated that this brightness increase, combined with the measured non-gravitational acceleration, means 3I Atlas must have lost at least 13% of its total mass during perihelion. That's not a small amount. That's 1/8 of the entire object vaporizing in a matter of weeks. When a comet loses 13% of its mass, you see it. Massive debris fields, expanding comas spanning millions of kilometers, bright, obvious tails pushed back by solar wind. The Japanese images from November 5th show no such tail. Comparison images of Comet Lemon taken the same day by the same observatory in Spain show a clear, bright tail extending 200,000 kilometers away from the nucleus. Textbook comet behavior. 3I Atlas shows a compact, concentrated brightness with no extended tail structure. Loeb posted about this on November 6th. He called it the 10th anomaly, non-gravitational acceleration without the required massive coma. In other words, it's pushing itself without the exhaust. On November 4th, Defense Scoop, an outlet that covers national security and defense technology, published something that should have been front-page news. The Pentagon's All-Domain Anomaly Resolution Office is monitoring 3I Atlas. Not advising, not consulting, monitoring. AARO is the office created by Congress specifically to investigate unidentified anomalous phenomena, UAPs, the modern term for what we used to call UFOs. Their mandate is to assess objects that could pose a national security threat. They investigate things that move in ways we can't explain, things that show up on military sensors, things that exhibit flight characteristics beyond known technology. They don't investigate comets. Comets aren't a national security concern. Comets are predictable, natural, well understood. Unless this one isn't. The Defense Scoop article, citing government sources, confirmed that NASA and the Pentagon both briefed Representative Anna Paulina Luna on November 6th. Luna had sent a letter to NASA's acting administrator demanding the release of 3I Atlas data, specifically the high-rise images from October 2nd. The government source told Defense Scoop that NASA intends to release relevant findings, data, and observations once the U.S. government reopens. That's not "we'll release the data," that's "we'll release relevant findings." Relevant to whom? Relevant how? Who decides what's relevant? And why does it take 5 weeks to release images that were captured in October? Meanwhile, amateur Japanese observers with consumer-grade equipment are uploading images to Twitter, and those images are revealing details that NASA's official releases somehow omit. Let's connect some dots. October 2nd, NASA captures high-resolution images of 3I Atlas from Mars orbit, not released. October 3rd, European Space Agency's ExoMars Trace Gas Orbiter captures images, released October 7th, 4 days later, but only after being described as challenging and showing the comet as merely a fuzzy white dot. October 29th, perihelion. 3I Atlas passes closest to the Sun, exactly when Loeb said any technological maneuvering would occur. Unobservable from Earth due to solar glare. October 30th to November 6th, NASA's Europa Climber spacecraft flies directly through 3I Atlas's ion tail. Instruments active, data collected, no word on what was detected. November 4th, independent Japanese observers release images showing concentrated brightness and no tail. Goes viral, 828,000 views. November 5th, Loeb publishes analysis stating 3I Atlas shows non-gravitational acceleration without the expected mass loss. Calls it the 10th anomaly. November 6th, Defense Scoop reveals Pentagon's UAP office is monitoring the object. NASA briefs Congress. Do you see the pattern? Every time an independent observation reveals something that doesn't fit the natural comet narrative, official channels go quiet. Every time someone with authority asks for the high-resolution data, they're told it's coming soon, but it never actually arrives. And every time amateur observers publish something that raises questions, the response isn't, "Here's the data that explains it." The response is silence. The Japanese observation network that captured the November 4th images spans 6 different observatories from Hokkaido to Okinawa, multiple independent instruments, multiple observation sessions, consistent results. The brightness concentration they measured has a full-width half maximum of approximately 2.1 arc seconds. For an object 1.38 astronomical units from the Sun, that corresponds to a physical size of roughly 1,400 kilometers for the visible coma. But here's the problem. If 3I Atlas lost 13% of its mass, as required to explain the acceleration, the coma should span at least 50,000 kilometers based on the expected expansion velocity of vaporized volatiles. It doesn't, not even close. The central concentration is too small, the tail is absent. The brightness distribution shows angular asymmetry rather than the spherical symmetry expected from thermal outgassing. None of this conclusively proves anything non-natural. Comets can behave strangely. We've seen fragmentation events, unexpected brightening, asymmetric outgassing, but we've never seen all of these things in the same object. We've never seen an interstellar visitor exhibit 9 documented anomalies simultaneously. And we've certainly never seen the Pentagon's UAP office monitoring a comet. The Japanese images don't tell us what 3I Atlas is. What they tell us is what it isn't. It isn't behaving like the comets we know. It isn't producing the debris field its acceleration requires. It isn't showing the structures we expect from natural outgassing. And the institutions with the best data, the high-resolution images, the spectroscopic analysis, the spacecraft observations, aren't sharing what they know. NASA says government shutdown, but ESA isn't shut down, Japan's observatories aren't shut down, China's Tianwen-1 isn't shut down, and yet the silence is coordinated, international, consistent. December 19th is 43 days away. That's when 3i Atlas makes its closest approach to Earth at 160 million miles. Close enough for every major telescope on the planet to observe it simultaneously. Close enough that if something is wrong with the official story, we'll all see it. The question is whether we'll be told about it before we see it ourselves. Subscribe for updates, because the independent observers aren't waiting for permission to look at the sky, and neither should you.